In this episode, we're going to start looking at how we can test more complex React components, starting with a React component that talks to an API and renders data from it. I've built a user component, which can fetch a user from the JSON placeholder API and render some data, their name and their website, onto the screen. So here is that component in action. It's fetched some data and it's rendered Leanne Graham's name and her website, hildegard.org, onto the screen. Just to be clear, the API I'm using is JSON placeholder. This provides a really good API that has loads of fake data, made up users, made up blog posts, all sorts of stuff that you can use for testing React component. It's particularly good if you're building a demo app or recording a screencast, for example, and need some data to work with. So in this case, we're making a request as /users/1, and we get the made up Leanne Graham back as the user with the ID of 1. To make sure we can test the HTTP request correctly in Jest, we need to make sure that fetch is available in the test environment. So I've gone into the test folder and found shim.js. This is where earlier in the series we set up our fake request animation frame, and I've imported whatWould-fetch, which is the polyfill to provide the fetch API for browsers that don't support it. Here's the code for that user component. So we have URL for user, which can grab the user for a given ID. Fetch user then uses the fetch API to make a request to get that user and pass it as JSON. And then we have our actual user component. It has some starting state where the user is null. And in the component.didMount lifecycle hook, we fetch a user with the given ID prop. When we get that user, we then set the state, so we store the user into the state, and we have a render function that checks if the state of the user is null. If it is, it renders the loading text, else it renders their name and their website. To test this, we don't actually want to make real HTTP requests to an API. In your unit test, you never want to talk to an actual real-life network. As much as anything, it's quite slow, networks can be flaky, and also the data could change. So you could write a test that asserts some data exists, but if that API changes, your test will start failing even though your code hasn't changed. It's much better to fake an API in tests to keep them nice and quick. To mock out our API requests, we're going to be using the fetch mock library. This is a library I found on GitHub that I've been using for a number of years now. It's a really good API that lets you easily mock out fetch requests. So just to save some time, I've already created the test file and put in some code that we'll need. So before we start writing our test, let's just walk through what we've got. So we're importing React. We're then importing the shallow API from Enzyme. In previous versions of Enzyme, you'd have had to use the mount API for this, because previously the mount API was the only API Enzyme provided that would actually call real lifecycle methods. So in previous versions of Enzyme, if you used that, the shallow rendering wouldn't call methods like component.didMount. In our case, for this test, we need component.didMount to be called because that's when the HTTP request is triggered. As of Enzyme version 3, the shallow rendering still calls those lifecycle methods, so we can use shallow rendering. I'll say it a few times throughout this course, but you should always use shallow rendering when possible, just because it does less work and therefore will be quicker to run than using the full mount API. So given that shallow does call the lifecycle method we want to test, component.didMount, we're going to use it for testing our user component. I then import the user component, and I also import the fetch mock library. We've then got this function NextTick, which is a synchronous function that will just resolve after one asynchronous loop has passed, because it has a set timeout with a timer of 0. So it's some asynchronous work that will almost immediately get run. We'll see why this is important in a minute. We then have our dummy user, which is the fake user that I'm going to mock the HTTP request to return with. Typically here, this will just be an object that has data representative of the data your API would give back. Note that the real-life API actually has loads more fields than ID, name, and website, but those are the only 3 our component needs to worry about for the purposes of this test, so that's all I'm mocking out. There's no point creating a bunch of other fake data that you're not going to use. And finally, down here I've got the test. I've written out the description, but there's no body yet. The test says it shows the loading text and then the data once it has been fetched. So we're going to check that when we render the component, it first renders the loading text, and then once the HTTP request is returned, it renders the right data onto the screen. So the first thing we're going to do is render our component. So I'm going to say const wrapper, as always, and we're going to shallowly mount the user component with an ID of 1. And now we need to check the text on that. So I can say we expect wrapper.find p.text to equal, and at this point the text should be loading. Let's save that and see what happens. Now you can see here that the test has passed, but we've got this large error message up here. It says unhandled promise rejection warning. So what's happening here is we're mounting the component which is triggering off the HTTP request, And in the jest environment and the way it's set up, that HTTP request doesn't work and fails. It's actually quite a good thing that it does fail because it gives you this horrible error message, which is a good way of spotting when you've forgotten to mock an HTTP request. So even though this test doesn't rely on the HTTP request, we still need to mock it. So let's use fetchMock to see how we might do that. So because our HTTP request gets triggered in a component did mount, I need to do the mocking before we mount the component. So I'm going to call fetchMock. And then you can call .get to mock a get request, .post to mock a post request, and so on. I actually like to use an alternative function called get once. This will mock the HTTP request to a given URL, but only mock it once, which is what we actually want here. I don't want to mock the request every single time, I just want to mock it once. This is a good practice to get into because it means that once this test makes a request to this API, the stub will be cleared away. This means you can't accidentally have another test relying on the fact that you mocked a URL in a previous test. So we're going to mock the URL, which we haven't got yet as a variable. We'll bring it in a minute. And then the second argument to fetch mock is an object of configuration. So we want to mock it with a status of 200, and our body is going to be the dummy user. It's really handy mocking it this way because it's clear that you're mocking a successful response. Say I wanted to test an error case, I could change the status to 404, for example, and maybe an empty body. And doing it like this makes it really clear exactly what you're mocking. To get the URL, we'll go into the user component and copy the URL from there. And once I put the URL in and mock the request, we can see that the test is now passing and we've got rid of the error. Now we can write a test that checks once we fetch that data, we re-render and we have the right data being shown to the user. What we need is a way to wait for the HTTP request from the React component to have been requested. And this is where our NextTick function comes in handy. When we mock a fetch call using fetchMock, it's still an asynchronous request. However, because it's mocked data and it's not hitting the network, it's an asynchronous request that effectively resolves with that mocked data straight away. So what we need is a way to queue something to run just after we know that HTTP request has been resolved. That's what our NextTick function does. It effectively queues on a bit of code that will run after all other pending asynchronous work, which will include the HTTP request, has been completed. So down here, what we need to do is wait until the next tick has happened. So what we might be able to say is we will await next tick. Async await is a new addition to JavaScript, which lets us more clearly write asynchronous code, but in a synchronous manner. So by saying await next tick here, this code will actually wait until the next tick promise has been resolved. At this point, we'll know that the fetchMock HTTP request has been resolved. And to use await within a function, that function needs to be marked as asynchronous. So we'll mark it like so. And now down here, we should be able to make assertions on the data. So I'm going to say I'm going to expect wrapper.find heading4.text. And at this point, this should equal the dummy user's name. Let's see what happens when we run this test. And you can see it saying method text is only meant to be run on a single node, not found instead. And this is because although we know that the React component has fetched the data's been resolved, and it's come back, Enzyme doesn't know. We need to actually tell it to explicitly update the wrapper. The wrapper object doesn't dynamically update as the React component does. Enzyme is good at knowing when you've triggered a set state change. For example, when you simulate a button click, Enzyme will update the wrapper for you because it guesses that something's probably changed, but it can't always know. In the case of asynchronous network requests, it would be impossible for Enzyme to know exactly when to update. So to get around that, we can manually call wrapper.update, and that tells Enzyme to update its representation of the React component. You can see once I save that, the test is indeed passing. And just to prove it's passing correctly, if I change the dummy name to Bob rather than Jack, you'll see that we expected Bob and we got Jack Franklin. I'll now duplicate this line and check that we're outputting the URL correctly. And this will be in a paragraph, and it should equal dummyuser.website. You'll see that this is also failing. The website is hpsjavascriptplayground.com, but in the component outputs it with URL in front of. So we can either check that string exactly, or I can change from using just to equal to contain, which will check that the string contains the substring of the website. This is quite a lot to have in one test, so let's look at how we might break this into two tests. We'll have one test that checks the component shows the loading text, and another that checks that it fetches the right data and renders it onto the screen. So for now, I'm just going to duplicate this test, paste it in here, and we'll change this one to say it shows the data once it has been fetched. And I'll change this one up here to be it shows the loading text before the data is fetched. I'll hit save and those are both passing, but we can do some tidying up now. For example, this URL exists twice, so we can pull this constant up outside of the describe, delete it there and delete it there as well. And we're still passing. We can delete these assertions down here because we don't need those for the test where we're checking the loading. And here we can do the opposite. We can remove the assertion that we show the loading text. Now there's still some duplication here. We've got this fetch mock.getOnce called twice. So let's pull out a function that makes it easier to mock the URL. So I'm going to say const mock URL with user. And it's a function that will take in the user and it will return the result of fetch mock.getOnce. And we know the URL, so we won't pass that in. And we'll say we'll return with a status of 200 and the body will be the user we've passed in. Now I can clear this fetch mock call here up to mock URL with user, dummy user. And I'll do the same thing in the next test as well and delete that fetch mock call. With that, we're still passing, but our tests are much cleaner and we've removed all the duplication as well. What I've found myself doing on larger projects where I'm using fetch mock across a whole host of components is we'll usually provide a little module with a few handy functions around fetch mock that makes it really easy to perform common HTTP mocks that make sense for your application.